Hey everybody, welcome back, finally back from the summer break, so we're back to tutoring now. So I thought I'd go over this dynamics problem that I went over with a student the other day. So this one is number 11.8. It's out of the Beer Johnston Dynamics book, which is the 12th edition, so that's the latest edition of that dynamics book. Alright, and this is from one of the first sections out of the textbook, so we're just going to be looking at basics like position, velocity, things like that. So this problem states that we've got the motion of a particle defined by this relationship. Okay, so we got t squared minus the quantity t minus 2, and then cube that. X is going to be expressed in feet because that's like your position, right? And t is going to be in seconds, it's just time. And we want to find a couple of things. We want to find two positions at which the velocity is 0, and we want to find the total distance traveled by the particle from t equals 0 to t equals 4 seconds. All right, so a few things to work on there. So first of all, what I'm going to do is I'm going to rewrite this equation because we're going to need it, obviously. So x is 2 squared minus t minus 2 cubed. All right, now remember this is position. What we want to do is we want to find the two positions where velocity is 0. Okay, well, obviously I can't get velocity here. I can't figure out where velocity is 0. So first thing we need to do is find velocity. Okay, so we need an expression for velocity, and we're going to be able to find that because we know that the velocity is the time derivative of x. All right, so it's dx dt. So I need to take the derivative of this equation with respect to t. Right, so let's do that. So here we got t squared, so derivative of that will be 2t. And then we've got the minus, and then I've got this quantity cubed, right? So remember we got to move the 3 to the front, rewrite what's in the parentheses. That's going to be squared now. And then we got to take the derivative of what's inside, so we just have this one little t here. So that's just going to be multiplied by 1. All right, derivative of negative 2 would be 0. Okay, so we are left with 2t minus 3 times t minus 2 squared. So that's our expression for velocity as a function of time. All right, and let's expand this out a little bit. So this is squared here, so if we were to expand that out, we know that's going to be t squared. Then we get minus 2t, so minus 4t. And then negative 2 times negative 2, so plus 4. All right, so let's write that in here. So we get 2t minus 3 times t squared minus 4t plus 4. Now let's go ahead, we're going to multiply through by the 3, and then we'll group up our terms. Okay, so let's go ahead and multiply through by the 3 first. So we got 2t minus 3t squared. We get minus 3 times negative 4t, so that's going to be plus 12t. And then we get minus 3 times positive 4, so minus 12. Right, and then let's group our terms up, and we've got negative 3t squared. We've got these two t terms, right? So we're going to have plus 14t and then minus 12. So nothing too difficult so far, right? Main thing we had to know is this expression here. So we had position, we can get velocity using this relationship. Now I want to know the positions where velocity is 0. So if this is the velocity expression, what should we do with this? Well, we need to know where it's 0, right? So let's set that equal to 0, and then we can solve for t. All right, so you could solve for t using your calculator or MATLAB, whatever you want to do. Just for the purpose of this video, I'm going to go ahead and do the quadratic equation because this is just a second order polynomial, right? So remember we're going to have negative b, which is right here, so negative 14, plus minus the square root of b squared, so it's 14 squared, minus 4 times a, which is -3, times c. And then everybody remember what the denominator is? It's 2a, right? So we're going to have 2 times -3. All right, so that's just your quadratic equation there. And then you go through and then solve. All right, so we're going to get 2 times. So we get 1.131 seconds, and then we get 3.535 seconds. All right, so at both of these times, velocity equals 0. Okay, so now we've got this. Now I want to find the 2 positions at these times, right? So how are we going to do that? Well, if this is our position equation as a function of time, that means we could take these times, plug them into this expression, and get the positions when velocity is 0. So let's do that next. Oops, I left off half the number here. So this should be 1.131. All right, we're going to plug that into this equation up here. So let's call this equation 1. All right. And if we do that, we're going to have 1.131 squared minus the quantity 1.131 minus 2, and then cube that. Now if you put that in the calculator, you are going to get 1.935 units. There will be feet. We know that because it says that right there. So that's one of our answers. Okay, then we do the same thing for this other time. So let's plug in 3.535 into that equation 1. All right, so let's square the 3.535 and then subtract 3.535 minus 2 cubed. And then that gives us 8.879. And again, that's feet. All right, so there's your other position. So these are the positions when velocity is 0. Okay? So still not too bad, right? We just take the derivative, we get our expression for v, solve for the time when v is 0, plug it into our position equation. So that takes care of part A. All right, now let's look at part B. So part B wants the total distance traveled from the particle from 0 to 4 seconds. All right, so let's do what kind of seems like we should, do first, which would be plug in t equals 0 and t equals 4 into this expression 1, and let's see what we get. Okay, so when t is 0, if we plug that into this equation here, we're going to get 0 squared minus 0 minus 2 cubed. And what's that going to be? 8 feet. All right, so that's 8 feet. Now let's look at 4 seconds. Okay, so just plug in 4 everywhere we have t. So we get 4 squared minus 4 minus 2 cubed. And what's that going to be? Well, this is going to be 4 times 4, which is 16, minus 2 cubed, which is 8. So 16 minus 8 is 8 again. All right, so now if you think about that, does that really make a lot of sense, right? Because we start at t equals 0, we have a position of 8 feet. And then at 4 seconds, we're back at 8 feet. Okay, so that means you've got a path that is not going in a straight line, obviously, which makes sense because this equation up here is a cubic equation. All right, so we don't have just straight line motion. We've got this curvy path that we're on. All right, so in order to find the total distance, we're going to have to kind of think about what's going on. And what I did to help show y'all what's going on is I went into MATLAB and I plotted these functions. Okay, so this top plot here, this is the plot of x equals t squared minus t minus 2 cubed. All right, and notice we went from 0 to 4. All right, and then I plotted the velocity equation. All right, so this one here was the negative 3t squared plus 14t minus 12. Okay, and again, going from 0 to 4. So I plotted these so you can kind of see what's going on. So here is our path. All right, so notice we're at 8 for x when we're at a time of 0, and then at 4, we're back at 8. So this is our path that the particle is taking. All right, it looks like that because it's a cubic, okay? Now, if we look down at the velocity, you'll notice I highlighted these little points. This was as close to velocity equal to 0 that I could get on here, just the way the time data is. But if you look, you can see our time is the 1.13 and then 3.5. So pretty close to what we had. Now, if you look at those same times up on the position graph, so like there, and then, I mean, you can say it's pretty much there. Notice what happens. We're coming this way, and then we're changing directions, right? So we're coming from here down, and then we start going back up. And then once we get here, we start going back down, okay? So what we need to do then is we need to find this distance right here. We need to find this distance, and then this distance. And then we add those up, and that will give us the total distance traveled as we go from 0 to 4. Okay? So I think it's easier to kind of see that plot so you can visualize what's happening there with that path. Okay, so let's do that. So let's look at this one first, then we'll do that, and then that, and add them up. All right. Okay, so let's do t equals 0 to t equals the 1.131. All right. And all we basically need to do is take the difference in the position. So I want to find where x, what the value of x is at t equals 1.13, and then, you know, the position location when t equals 0, which we already calculated that to be 8, and then take that difference, because that'll be the distance traveled. And we don't really care about the sign, so let's just do the absolute value. Okay, so x at t equals 1.131 minus x at t equals 0. All right. So notice we already have this value. We found it up here. Okay, so it's 1.935, and then minus x at t equals 0, well, that was 8. Okay, so that's going to be 6.065, that's feet. So it takes care of that first part of the path. So from here to here is the 6.065 feet. Okay. And then now let's do the second one. So now t is going to go from 1.131 to t equals 3.535. Again, we don't care about the sign, so let's just do the absolute value. And now let's do x of 3.535 minus x at t equals 1.131. Okay, and we've already got these values solved for. So this one at 3.535 is the 8.879. And then subtract off the 1.935. And this is 6.944 feet. All right, so that means from here to here is 6.944 feet. Okay, and then we need to do this little piece last. So now we're going to go t equals 3.535, 3 there, to t equals 4. All right, so x at 4 minus x at 3.535. Do the absolute value there. So x at t equals 4 was 8, and then subtract off the 8.879. All right, and then that's going to be 0.879 feet. Okay, so that's this little piece right there. Okay, so now that we've got that, we can add these three numbers up, and then that gives us that total distance. So let's just add those three numbers. All right, so that is going to be 13.888 feet. So that's the total distance traveled in those 4 seconds, going from 0 to 4. All right, so that's how you go about doing that one. Hopefully that all makes sense, and I will see you next time for another tutorial.